Hello dear students. In this video, we will see how to execute pop operation on stack using array. In the previous video, we saw push operation in big detail. Now we will see the pop operation. Let's look into main first because main is going to call the pop operation. If the option given by the user in the menu driven program is 2 for pop a value, that means if this case 2 becomes true, then we have decided to call pop. But then be careful. Pop means you are removing a value from the stack. But to remove a value from a data structure, you should first confirm that this data structure is not empty. So we have made one if statement over here where we are calling a function. This empty is a function which will check whether the stack is empty or not. And if the stack is empty, then it returns true, and true means 1. Whereas if the stack is not empty, that is false, then it returns 0. And this 1 or 0 has been clubbed with the if. So just imagine for some time that empty returns 0. That means the stack is not empty, and 0 means false. So what do you see in the bracket of the if? The bracket of the if has false, and whenever the condition is false, else executes. So when is this else going to execute? Only if the stack is not empty. That is, the stack has some values that can be popped. In the else, we are calling pop by passing address of the stack as usual. And we are returning the value that we have deleted. Store it in Z and finally print the value of Z using printf. Let's look at empty function. The empty function here gets the address of the stack, address of S. That means P is a pointer which will point to S. Recall, when is such a stack empty? The stack is empty if top is -1. Recall from our first video in this series, stack using arrays. So we are inquiring, is P arrow top equal to -1? Just peep in P arrow top, this top which I am underlining is 2. That means it isn't -1. So return 0 will execute, and 0 means false. So what is empty shouting? This function empty shouts that this stack which you are inquiring is not empty because it is returning 0, false. So a very simple empty function which only inquires the value of top. If top is -1, then the stack is empty, so it returns true, that means 1. Otherwise it returns false, that means 0. Okay, now let's inquire what is pop going to do. It's a very simple function. Just see, before I run this pop function, before I actually execute it for you, the pop function, this one. Just observe the stack drawn here on the right. You know that the values of the stack are 10, 20, 30. Wrong. I am wrong. It's not 10, 20, 30. It is 30, 20, 10. Even while you are asked which values are there in the stack, you should read it from last in, first out. So 30, then 20, and then 10 because 30 is the topmost. Check the value of the top. Top is 2. So this is the index 2 at which the topmost element has been stored. So if you are asked to pop a value, obviously 30 should be popped first, isn't it? So let's see what pop does. It gets the address of S again. So P is the pointer which points to S. We have declared one local variable X where X stores value from the array. A is the array. But which value does it store? Check the index written with the array. It is P arrow top. And P arrow top right now is 2. Check the diagram. Here I am underlining. P arrow top is 2. That means whatever is the value of A2, come on, A2 is 30, isn't it? Will be stored by X. So in this situation, X is 30. And listen, this value 30 is returned in this final line. You see, return 30. It returns it back to main, as if this function pop is saying that my duty was to remove an element. But I have not only removed the element, but I have also returned that element back to you, so that you know, main, you know that which value was actually removed. Okay, but before return x, we have got one more statement, p arrow top minus minus. It's obvious, isn't it? Tell me, if we have taken this 30 and stored it in x here, and we are going to return this 30, then we should decrease top by 1. That's top minus minus here. That means top, which was 2, will now become 1. And really so. Now the stack has only two values. Which one? 20, 10. 20 and then 10. Because 30 has been returned due to return x. And that's the end of pop function. Something interesting you find here. Something interesting, although I don't know how much interesting you will find in that. But actually, we are telling that we have removed 30, isn't it? Yeah, pop means removing 30. But 30, as you see, is still there in the array. There is nothing called erasing a value from the array or erasing an element of the array. Remember, array always has fixed size. So 30 is not going to go anywhere. 30 will remain in the array. But is 30 popped? Yes, it is popped. Because most important thing is top, which was 2, has now decreased to 1. So now logically you are saying that your stack has the boundary up to 1 now. And 20 is the topmost and 10 is below 20. I hope you are understanding what I am saying. Okay, let's execute this pop function again. Although I know enough, you have understood what I am talking about. But just for the sake of repetition, execute pop again. Suppose we call the pop function again. Then x is declared and x stores array value. A is the array. Which element are we talking about now? Watch that p arrow top is 1. Watch the diagram on the right. Check the value of the top. Top is 1. So a of 1, here we go. This is 20. 20 is stored by x. So it is as if, we have copied that value which is at topmost in a variable called x. And finally, we are going to return that 20, return x. But before returning x, we are decreasing top by 1. So top, which was 1, will now become 0. Isn't it so? So top is no more 1, it is now 0. So you again see that this 20, we are claiming that we have removed 20, but there is no way to erase this 20. This 20 is still there in the stack, but it is useless now. It is as good as not there because our stack has the boundary up to 0 because top is 0. And that's how the pop function runs. Okay, what will happen if you call pop once again? Just pause the video and tell me what will happen. But then what will happen if you call pop again? Obviously 10 will be stored by x, needless to say, and top minus minus. That means top, which was 0, will now become minus 1. Great. What's so great in that? Look, you have claimed that you removed 30, you removed 20, you removed 10 also. After removing 10, top, which was 0, has now become minus 1. And when top becomes minus 1, this stack is empty, isn't it? Obvious. If you keep removing values from the stack one after the other, there will be a point when top will become minus 1 because every deletion, every removal decreases top by 1, isn't it? Now the stack has become empty. Now, if somebody or rather operator on this empty stack, just check, the stack is now empty and operator is ignorant about it. And operator says that I want to pop value. So this case 2 runs, obviously, But this empty and is the stack empty? Yes, it is true now. Stack is empty. So, wait a minute, let me clean up a few things. This time, when pop is invoked, I mean the case 2 runs, it will first inquire, is the stack empty? And it is empty. So this is going to return true, that is 1. And now if bracketed if here has a true value inside. So when if is true, it is going to announce stack underflow and it will not go to else. It will not dare to pop because there is nothing to pop, isn't it? That's the way how empty function helps the pop function to carefully call the function so that proper value is popped. So in this video, we have seen two functions, empty and pop. I think we have some more time where we can see the display function. Let's see how to display the stack. Just see, suppose we have a stack like this, S, and again, in this S, we have the array A, okay, and A has size 5 as you all know, and we have stored just three values like 10, 20, 30. We have just now stored three values. So top is 2, and we want to display this stack. Now, if you want to display the stack, what will be the output? Yes, the output will be 30, then 20, then 10 will be printed on the screen. Not 10, 20, 30, isn't it? So how do you display the stack? Again, pass the address of the stack. So P is the pointer which points to S, stack. Now have a look at this. It's the problem of simple for loop where we are displaying the array. We will declare a counter I and we will ask I to start with P arrow top. You observe that P arrow top right now is 2. So I will begin with 2 and I goes up to 0 every time I decreases. So what will happen in this for loop is I will be 2, loop will run, I will be 1 and I will be 0. This for loop which I am marking, this printf will run for all values of I equal to 2, 1 and 0. And each time this printf runs, we are printing P arrow A square bracket I. Now listen, first time I is 2, next time I is 1 and last time I is 0. So A2, A1 and A0 are printed one after the other. So 30, 20, 10 are printed. And that's it. After the for loop, we have ended the display function. So to display the stack, simply start a counter I from the position of the top and keep decreasing I by 1 till I reaches 0. So as you are going down to from top to 0, you are bound to get the values as 30, 20, 10 at the output screen. The last function destroy is really not necessary, but still I have written what it does is it destroys the stack instantly. That means it claims that I have removed all the values from the stack instantly. Listen, pop is going to remove only one value at a time, whereas destroy will remove all values instantly. Interested readers can read this destroy, but it's not so important. Finally, I have written all these functions or defined all these functions below main. So it is important for all of us to declare these functions above main. So these are simply the declarations made. Why? Because all the body of these functions have been defined below the main. So just take the first line of the function, first header line of the function and end it with semicolon. These declarations are important when you write the functions or define the functions below main. So all these functions have been declared. That's it. This is how you create stack using array. And in the next video onwards, we will see queue data structure. Thank you very much.